Hello everyone, Saidu here. Welcome to another CCNA Cyber Ops Lab. This lab is about Snort and Firewall rules. The device that I will be using is the Cyber Ops Workstation VM and an internet connection. So in the Cyber Ops Workstation, I have a Mininet environment, which is the environment that I will be using for this particular lab. So basically, the Cyber Ops Workstation VM is a container for holding the Mininet environment. Now I'll go to my prompt here and execute this command to start the lab. So from my prompt here, I will enter this command in order to run this script so that I will configure the network for this machine. So enter sudo, execute this lab.support.files, then configure as DHCP.sh. So specify the password, which is CyberOps. Now to check this connectivity, I'll try pinging cisco.com to see if the ping is successful or not. Say ping cisco.com and the ping is successful. So the network configuration is fine. It's up. Now, the firewall and intrusion detection system, or the IDS, are often deployed to partially automate the traffic monitoring task. Both firewalls and IDS match incoming traffic against administrative rules. And IDS and firewall rules have different structures, but they do have some similarities between some of the rules. Example is the matching component and action component. So both the firewall and IDL rules contain matching component and action component. And the matching component specify the packet element of interest, such as the packet source, the packet destination, the transport layer protocols and ports, and data included in the packet payload. And then the action components specify what should be done with that packet that matches a component, such as accept and forward the packet, or drop the packet, or send the packet to a secondary rule set for the inspection. A common firewall design, or a good practice of firewall design, is to drop packet by default while manually specifying what traffic should be allowed. So the purpose of this is to protect the network from an unknown protocols and attacks. And it is also highly recommended to log events that occur. Now from my prompt here, I'll run the script. I'll run this script to start the mininet. I'll use sudo lab support file script cyberops extended top.py and specify the password, which is cyberops. Now that went well. So from this prompt here, which is the mininet prompt, I'll enter the xterm command and space R1 to start or to open the shell of R1. Now from this R1, I'll start the Linux based IDS Snort. So from the R1 prompt, I'll enter lab.support.files script start snort.sh. So and as you can see from this command line, it's running in the IDS mode now. So I'll go back to the CyberOps Workstation Mininet prompt and start two more hosts. I'll start the H5, xterm H5, and I'll start xterm H10 to start the host 10. And the host 10 will simulate a server on the internet that is hosting malware. On H10, I'll run this mal server start.sh script to start the server. So I'll come to my H10 node and run this command, say lab support files script mal server start.sh, and the server is running. So running the command net start -tunpa show me that the lightweight web server nginx is running and listening to connection on port 6666. So I already have the instance of Snort running in my R1 terminal window. So to enter more command on R1, I'll open another R1 terminal by entering the xterm R1 from my mininet terminal there. Now these windows are getting much, so I'll arrange them on my screen here so that it will look nicer. So on this new R1 window, I will run the command tail -f var log snort /alert. So this command monitor the snort rule in real time. So the -F option monitor the alert in real time. Now because no alert were yet recorded, the log is empty. And then from my host 5 or the H5 window, I will issue the command wget, then the IP address 209.165.202.133, and then I'll specify the port number, which is 6666 slash w32.nimda.am.exe. So what this command will do is to download a file named w32.nimda.am.exe. Now the file has been downloaded already. You can see now that the IDEs have already generated an alert to the file download. Now from this alert, you see the date and time the system record this alert. You see the system record this alert. You see the source IP address and the destination IP address, and you also see the source port number and the destination port number. But this timestamp may vary depending on when you do your own lab. So based on the alert shown, the message recorded by IDS signature is malicious server hit. So now on H5 or the host 5, I'll use the TCP dump command to capture the event and download the malware file again, so I can capture the transaction. I'll issue this command from the prompt, say TCP dump -I H5, specify the interface, and -W, and then specify the file name, which is nimda.download.pk. The purpose of this ampersand symbol at the end tells the shell to execute a TCP dump in the background. You notice the process ID there. So I'll press enter so that I'll regain the control of the shell while the TCP dump runs in the background. Now, as we have the TCP dump running in the background or capturing the packet, so I'll issue this command or the download again. I'll use wget, the destination IP address, and then a file name, which is w2.nimda.am.exe. So I got the file downloaded again. To stop the capture, I'll do this. I'll stop the capture by bringing the TCP dump to foreground with the command fg. No need to specify the process ID because it is only TCP dump that is running in the background. So to stop this TCP process or TCP dump process, I'll simply enter the control +C from my keyboard here. So the TCP dump process stops and this displays a summary of the capture. That is the number of packet it captured will be different from your capture. Now if I check my H5 or if I check the host 5, I should be able to find the nimda.download.pk file. Now this is the file. Now Wireshark can be used to analyze this speaker file. Now let's do something different. Turning firewall rules based on IDS alert. While I am on my mininet prompt here, I will issue the command xterm r1 to start the r1. So from the r1 window, I will issue the command iptables to list the chains and their rules currently in use. So I'll use the command iptable -l -v. So as you can see here, we have 3 chain. We have the input chain, we have the forward chain, we also have the output chain. Now something to note is that the connections to the malicious server generate packet that must traverse the IP table firewall on R1. And packet traversing the firewall are handled by the forward rule, and therefore that is the chain that will receive the blocking rule. So now to keep the user computers from connecting to the malicious server identified in the first example, I'll simply add the following rule to the forward chain on R1. So from my command prompt here, I will say iptables -I forward -p to specify the protocol, -d to specify the destination IP address, and -d port to specify the port number, and then -j to specify the action, which is drop in this case. Now to confirm that this rule has been enabled, I'll enter the IP tables -l -v again. Check that out. Now, if you can see very well from this chain forward, you see that we have a rule that drop any packet that is destined to that particular destination. Now, from my H file, I'll try downloading SIM file with the command wget, the IP address, and the colon, the port number, and then the name of the file. So as you can see here now, the connection will not be successful, will not succeeded in connecting to that particular server. So if I wait a bit, it will still be the same. Now simply end it using the something we notice here is that the connection or the firewall is blocking the connection to the malware hosting server. Alright guys, that was some little stuff about the Snort and Firewall. I hope you learned something from this video, and I will see you in the next one. Thanks.